So I'm going to give you a little sort of insight into Microsoft and how we run our cyber threat, our threat intelligence operation, and then what I think is probably, we'll call it a small epiphany last year, looking at where we were certainly going and where the industry was going. And I think that it's really important to understand this sort of paradigm shift around security controls and how they're being used, because it really factors into the type of people you want to be hiring, how you should be looking at evaluating products, and how you're going to be operating these systems in the future. And so just quickly, just to sort of set up, Microsoft certainly does have, a lot of security professionals. About 3,500 is the number we publicly talk about, working on various types of problems. We have a specific threat intelligence cell. They're half engineering team and half set of traditional threat analysts. And so things like Office 365 APT, all the detonation technology we do around attachments, that's mostly built by these organizations. You will see us come out and talk about publicly their blogs or a threat intelligence report, and we'll use, we name threat actors or activity groups based on names from the periodic table. And so when we talk about Strontium, FireEye is going to call them APT28, CrowdStrike's going to call them Fancy Bear. Okay, that's just our naming convention. So I get asked all the time, so John, how do I get access? We know you have about 1,000 plus traditional workup threat intel reports in your library. We actively track about 70 plus groups around the world. And the way we get access to those, because we think that it's just, having access to, reams and reams of documentation doesn't make sense for most organizations. If you're using the higher end security capabilities in the cloud, we're going to pop those reports for you when there's a correlation to a specific attack based on TP tactics, techniques, and procedures, motivation, tooling we see, where they're coming from, and so on. And so that's all available. We also have, at least we used to do this semi-annually, now it's an annual report. So this is sort of our TLP green threat intelligence sort of trends for the year. It references, we sometimes do a case study or deep dive on a couple specific sets of threats. In behind this, there's a whole bunch of blogs that are available on the various Microsoft properties that talk in detail about some of these different types of attacks that we see and how we detect them. We've got a huge incident response team that unfortunately has been in Canada way too much in the last couple of years. Okay, so I'm going to start with a bit of a story here in terms of this infamous MS-08067. This was a vulnerability that popped back in 2008. We actually released an out-of-band release from our normal Patch Tuesday cycle back then. I was working at Department of National Defense at the time, and I remember this one well. Microsoft, MSRC, Microsoft Security Response Center, and our threat intelligence team, we identified this before. We were actually the sort of the finder of this. It was a 0-day. It was remote code execution, so it was wormable. It was pre-auth, meaning didn't have to authenticate to use it, and you got basically system-level access, and it affected every single version of Windows. So, on the scale of things, pretty bad, right? Pretty bad. And so you walk down the hall to the crisis engineer in Microsoft Security Response Center, you tell them those characteristics, and all of a sudden, their hair stands on end, and the whole organization mobilizes to deal with this. And then this one, back in those days, we weren't really good as organizations at patching machines, right? And so while we did do an out-of-band release and we updated, hundreds, if not millions of machines in a very short period of time, there was lots of machines that weren't patched for a long, long time. And so this one had a bit of infamy. This is the only actually vulnerability that I know of from Microsoft that actually had its own t-shirt, coffee mug, set of throw pillows, and had a couple cakes based by pen test teams around the world because they'd get engaged for a specific customer to go and scan their whole network and see if they can get access, and they would go in and use something like Metasploit, which had this built in pretty quickly, and they would pop the domain controller within the first 30 minutes, and then they could sit back and just watch everything that was going on. So that was the old days. Fast forward to today. Just in terms of wrapping up, how we actually found out about this was actually from the Watson, the crash data. right? That sort of, have an application that's crashed, I click the send report to Microsoft, and that data goes up to one of our big data systems. And this is sort of the very early days of using signal and telemetry to drive security capabilities at least in Microsoft world. And so you look at the sort of detail in here. This wasn't a really prevalent thing. This was actually ranked number 45,000 in the crash bucket, and sort of way we sort of categorize these things. And we saw 2 occurrences, right? So this is living in the tail of data, way, way, way down there. Fast forward to 2018, 2017, we've got a lot of great examples. I'll show you a few more of those as we go along here. Something like Bad Rabbit hits, this sort of malicious ransomware in the Ukraine and in Russia, and we've got this sophisticated machine learning systems built into the client technology as well as into the cloud, and we're able to block these things. So holy grail of defenders, block at first sight, never been seen before in the wild, no signatures available. And within 14 minutes, we're able to do, block all of the original, the early outbreaks of these attacks. No human intervention, right? That's really the trend you're going to see because, we've heard constantly there's a cybersecurity skills gap, and these attacks just propagate too quickly. There's too many of them, they propagate too quickly, and having somebody in a traditional sense, an analyst that sees a piece of malware, reverse engineers that, creates up a signature, ships out a DAT file, it doesn't scale in today's digitally connected world. There's a lot more detail on that in MSO 867. I'll have to give credit to a lot of this content. Like any good speaker, what I do, I steal other people's content. And so in this case, John Lambert, who's a distinguished engineer, he runs the Microsoft Threat Intelligence Center. I spent a week with John when he was here in Canada back in the fall. He spoke at Sector. He keynoted Virus Bulletin. There's a lot more sort of content. Actually, his session on at Sector is available publicly online, sector.ca. It goes into a lot more detail on MSO 867 and Watson. What I want to get to is sort of this notion, this example with Bad Rabbit is where these systems and this fundamental shift, I think paradigm shift around these controls that's happening, and it's not just with Microsoft, but certainly with many of the leading security organizations. And so we're kind of moving from this world where we had security technology to protect data to having the data actually providing the secret sauce to enable modern security. So that seems like, what the heck are you talking about, John? Let me explain that a bit more. And so in the new world, customers are absolutely at the center of this. And so, as I said, in the old ways, I had a security product. I had a bunch of smart engineers that had a bunch of IP, rules, algorithms, whatever those were, and then they shipped a particular product that was used to protect customers and protect their data on premises. And we've seen a shift where now what's certainly more important and much more agile and much more flexible is that we have a set of products, but the secret sauce and what really fuels the capability of those products is all of the signal and telemetry that is generated through the customer's use of those products and services. And so this is sort of, certainly the cloud effect. You benefit from all of the bad stuff that everyone else sees when you're operating in the cloud, in that connected world. And so if you talk to somebody who's building one of these systems, an engineer, who's building the machine learning model, certainly there's a lot of some science that goes into actually building and the right machine learning model. But if you ask them, and what would really make your system better, they would say, I want lots and lots of data from lots and lots of customers, not just lots of data, but lots of data from lots of different customers, so different industries, different domains, different geographies. I want the people at the pointy end of these attacks, like the UN, like Boeing, like Department of Defense in the US, like those types of customers that are really constantly attacked, because you're going to get really sort of cutting edge, unique and new things are going to be seen. And all of that signal then gets fed back into these models that are constantly learning, constantly tuning. And so I think that's really important because, in the past when we looked at evaluating security products, it was, you asked who else used the customer, who are your other customers? And you ask those questions because you wanted to understand the maturity of the product, how long has it been out, it's version 5, okay, it's stable, you're trustworthy, and so on. Now, that's still true, but it's, I think, almost more important that who else is using them. So if I'm an energy company, right, I want to know that there's a lot of other energy companies using that, because I'm going to benefit from all the bad things that those other energy companies. Remember, actors typically target, threat actors will typically target specific domains, right? They're going to get business domain knowledge on financial industry, energy industry, other types of industries. And so it benefits to you to be in an ecosystem where there's lots of your competitors also being attacked. Make sense? That's number one. Number two is that these systems are multidimensional, meaning that they can use a combination of zoom levels, that they can, they need to scale quickly, they need to deal with massive amounts of data, they need to make decisions, at some points very quickly, but then also tune things and send things for further analysis, and to be able to have that learn and drive insights as we go along. They're certainly what we call signal seeking, and so they both consume and then they also create, and I'll give you some examples of this, some data to tune thresholds, different types of confidence levels, and inform how things are certainly prioritized, because we have tons and tons of data. We can't analyze everything extremely thoroughly. We've got to really be smart about what we choose to do further investigation on. And then the last piece here, which I think is really important for how you're evolving and how we are trying to, at least from the Microsoft perspective, solve a lot of this skills gap around cybersecurity, and the fact that you don't need a whole bunch of super smart people to try to take these raw threat feeds from all these organizations and then integrate them into an ontology within my SIEM and make sense of all of that, is that these systems are much more, we're shifting to where, these algorithms are something that you're going to fine tune and work with, but you're not involved every single time. In that bad rabbit example, there was no human intervention. So you're monitoring, you're tuning these algorithms, you're improving them, adding your own, and I'll explain how we're able to do that. That was some recent announcements at RSA. So that's a super important point. Everybody's kind of, the big players are certainly doing this, so it's not just Microsoft. I think here CrowdStrike analyze and correlate over 50 billion events per day, and FireEye's got, a big, some odd million node mathematical graph database. Certainly that's interesting. I think that the challenge with some of this is integrating these things together into the other things that you have. And then certainly, consider that, the breadth and depth. I mean, part of the fact that we have such a large ecosystem of both consumer and enterprise is that we do have every type of organization from every geo around the planet. So to get just a little bit theoretical, and then I got to stay on time here certainly, so I'm going to go through this pretty quickly. We call these different types of systems, at least internally here, we call it now, near, and deep. So you can think of this as a funnel. And so at the now answer, and I'll use the example of Windows Defender ATP. So I see a file that gets dropped on the system. I need to render a decision on that really quickly so I don't bung up the user experience, right? And so this is like a lot of data. Same thing for email systems where I got a pipeline of email coming in. Millions of transactions per second. And I need to be able to quickly render detail on that. And it's sort of verdict oriented, like do I block, do I allow? And then once we get to near, we can do a bit more analysis. This is sort of milliseconds to multiple seconds. And so at this point, I might push a sample of that email or that attachment up to, say, the cloud to do a detonation in a sandbox is one good example of that. And then that's going to also, we get a lot of telemetry that is generated out of that. What did that thing do? Did it right to the registry? Is it going out to some command and control server? All of that then feeds back into this type of system and then can be used to maybe provide additional blocks or additional insights down to that client as we at a sort of near time, not just real time. And then finally, the last level here is where we think about doing deep analysis over time. So we're looking at large data volumes. Maybe we're looking at data sets over the course of a week or a month, or we're going to look at all tenant sort of traffic for a specific type of analysis we're doing globally, like what's going on across the board. And then all of that can then get fed back in. And so how does this, maybe taking this that step level, if we think about these telemetry-centric controls, right, and this is about the customers, this is the customer's telemetry, the data that's being fueled by use of the system. We're going to do some bucketing here when first things first come in to sort of categorize it really quickly, and then we want to benefit from the insights of things we've already analyzed, so do that matching so we don't duplicate and optimize that type of system. Then we're going to do some labeling to apply to things we know are either it's unknown, it's risky, it's malicious. And then next on that list, we're going to do some promotion of those signals, and this is where we determine what do we want to analyze further. And this is where there's a lot of secret sauce of engineering, a lot of smarts put in, because obviously like I said before, we can't analyze everything thoroughly to the same level. And so we've got to really be smart about what we prioritize within this system, and design the system so that it learns. So if we miss something down the road that should have been prioritized, that's factored into the algorithm, the model, so those types of things are caught next time. And then so the way this kind of works is that these signals kind of go down through the funnel, and then the labels or the verdicts kind of get promoted back up through the funnel with the sort of the insights and the client-facing things that happen sitting at the top of that. And then we have this sort of supervised automated learning that happens around these different types of systems, where we have this certainly resilience built in, and probably don't have time to talk about it today, but certainly, the threat actors are looking at how do we start to game these type of systems and find the chinks in the armor of these type of systems. So they need to be robust. And also, we have this notion of human over the loop. So in the Microsoft marketing material you would have seen at RSA or other types of keynotes, we talk about that underlying technical system that we've developed over the last decade as what we call the intelligence security graph. So all of that underlying system, this chart here just provides some example numbers. There's big numbers on there based on Azure Active Directory authentications, huge numbers there. We process more email than any other organization on the planet. Looking at that for malware, we've got this search engine that crawls the internet looking for all sorts of bad things, in addition to helping return search results much quicker. We have a whole digital crimes unit that works with law enforcement globally, does all these botnet takedowns. We have a whole threat feed of infected botnet machines that we then correlate and feed into these different machine learning models. And so from that funnel, the kind of way this works, and here's an example of Bad Rabbit. There's Doughfoil, Emotet, Ursnif. These are all examples of where we use this sort of machine learning pipeline and all of this sort of advanced analytics fueled by customer data and our other threat intelligence that I just described, to really provide that block, that sort of block at first sight with no human intervention. And so, big questions I get asked is, okay, so great, John, I want access to that. How do I get access to that? I have Office 365. How do I get access to all that threat intel? And last year we released an API so that you can use take what you have, your ArcSight SIEM, your Splunk SIEM, your different types of tooling that you have, your investigation tools, Excel, whatever the heck you have for that. Excel, the most used, the most prevalent tool used in the SOC anywhere on the planet. And so the idea here is that you're not pulling out raw threat intel. You're able to navigate the graph, right? Everybody remembers graph from the nodes of a graph from their high school math, right? Attackers think in graphs, and what we see historically is defenders think in lists of PCs, lists of users, right? Lists of network blocks. Attackers don't think that way. They think this device can get me to this user, to that user, can get me to that device, gets me to that database, right? That's a graph. And so the API lets you automate your SOC system to be able to interface with all that knowledge I just talked about in the graph. And then we came up with this, we always have kooky names for things, but this Intelligence Security Association that is basically a whole bunch of your traditional security vendor products that pre-integrate with that graph, so you don't have to do the heavy lifting on the API integration. So that was last year. I know I'm going quickly, but Brian's standing there to my right with the, I'm sure with the bell This was probably the biggest announcement we had at RSA a couple weeks ago. And so Azure Sentinel is our cloud native SIEM tool. And certainly what that lets you do is, as we have more and more data, most traditional SIEMs aren't so good at pulling data out of the cloud because there's just a lot of data there. So this is a cloud native SIEM. You don't have to worry about setting up infrastructure. You don't have to worry about setting up hardware. What's the database sizes that's required? You don't need to worry about any of that. You can just focus on fine tuning and, in fact, bringing your own threat intel into here. And so the two pieces I wanted to highlight here before I wrap up with Azure Sentinel. It's available in public preview. You can just spin it up and start using it. Bring your Office 365, all your Office 365 data for free. No additional requirements there. Even a preview, I don't even think there's any costs with the preview program right now. So the key thing here that everyone's been asking about, okay, I might buy some threat feeds from FireEye. I've been talking to Bob about this. If Bob's still here, how do we bring CCTX feeds and snap those in to make it really easy for organizations at scale? This is what Sentinel allows you to do. Okay, bring your own threat feeds and correlate those within all of the things that Microsoft is already doing for your cloud properties. And then a huge focus you've seen us probably over the last couple of years with the acquisition of things like GitHub, Azure Notebooks, so Jupyter Notebooks, knowledge sharing around how to, code snippets, how to reproduce something, how to protect against a certain type of attack. That's all getting built in. John Lambert's a huge proponent of building community knowledge sharing, tooling up everybody. He keynoted AttackCon, MITRE Attack, the conference there a couple months ago. Talked about some of the stuff we're doing. We've been talking quite a bit about CSE also with some of the sharing and the new Cyber Center. But some really innovative things there. What I don't have on here, I guess the other announcement at RSA was Microsoft Threat Expert, so tapping into our threat analyst team sort of at scale as a managed service in behind that to help with some of your investigations, to augment your own team was another piece that we're starting to build out. So I think I'm at time. I'm going to just wrap that up. I'm around here for the rest of the evening too for questions and networking.